right, as you look at this problem, ladies and gentlemen, today we're going to obviously look at two more types of inequalities that you should be able to solve after today, hopefully. And if you look at this, look at the problem. Does anybody have an idea what property would we have to use in order to get x, to get a hold of x? Melissa?
Distributive?
Distributive property is correct. So how do you do that? Can someone explain to us, remind us, how do we use the distributive property? Maya?
Well, 4 times 7 is 28, and then 4 times 3 is 12x.
So you're telling me that you take that 4, remember we called her Julie?
But she had the boyfriend.
She's a player.
Who?
Julie.
I'm just wondering what the girls were doing back here.
I was just pointing it out.
All right. Can you see? Can you see out of your eye? That's good. All right, everyone's good.
I can't see.
Sometimes you get, see Trey, you don't have to worry about having makeup all over your eyes. See what women have to go through?
Well, unless you don't wear it.
Huh?
I got hit in the head and I'm seeing blurry.
Well, unless you don't.
You want me to hit you in the head? Is that what you said?
I got hit on the head.
Oh, you got hit.
No, now I'm seeing blurry.
All right, here we go. So,
Hit me on the head.
Trey, you done? So this term right here, we referred to this as Julie when I first introduced it, Canyon. And when we distribute, remember, we use what operation, Ben? So we're actually distributing a factor of 4 to each term inside. So remember, we use our little arrow. So like Maya said, if you put a factor of 4 with 7, you get a new number of 28. So 4 times 7 is 28. And if you distribute a 4 to negative 3x, what's our new x term? John? Nathan?
12x.
How much?
Negative 12x.
Thank you. Negative 12x. And if you look at the problem, just like when we had equations with distributive property, after you distributed, does this not look like something you might have done last night for homework? Now we're back to something you already know how to do. So from here, what's our next step? Brian?
Subtract 28 from each side.
All right, so we're going to get our x term by itself first. And now what do we have left on the left-hand side? Trey?
48.
Excuse me?
Negative 48.
I said left hand.
Oh. Negative 12x.
All right. So even though I put a negative 28 over here, I don't flip this, or do I?
No.
Not yet, because that's, remember, really this is what operation?
Subtraction.
Subtraction, because remember when a negative is really subtraction, so that doesn't apply the rule of flipping the sign until we multiply or divide by a negative number. So we got negative 12x, and now Trey, the right side is equal to what?
Negative 48.
Thank you. All right, now, what's our last step? What are we going to do next, Hannah?
We're going to divide.
We're going to divide by what?
Negative 12.
Negative 12. What's the answer? Gia?
X is greater than or equal to 4.
If you notice, she actually flipped this based on the fact she divided by a negative number. And when you divide by a negative number, we also want the opposite of the inequality sign. So what's negative 48 divided by negative 12? Gia said positive 4. Everyone agree with Gia?
Yeah.
If you do not, you might want to ask a question. All right, now we're going to graph it, just like before. Are we going to have an open dot or a closed dot?
Closed.
We're going to close it, which means, what does that closed dot mean on 4? What does that actually tell you as you look at that graph? Ben?
It could be 4.
It- It could be negative 4. You mean 4?
Oh, yeah, 4.
4. So it could be 4. So we could plug in 4 to check. All right? So which way is the arrow going to point? Justin? Right. To the right. Nice. So now, our last but not least, we have to check. And Lainey, we're checking. This is what we do. Just making sure you don't forget, okay? All right, you got it? With me? All right, all right. I hate when I forget to do something, you know? Don't you? We all do. Maybe you're human, honey. All right, so we got that. And what do you want to plug in for X? Who'd like to? Alexa, what would you plug in?
4.
You could plug in 4. Sure. Does it matter? Anything greater than 4, right? So you can do 5, 6, 10, 100, whatever you want to do. All right, so are you guys cool with 4? I'm going to do 4 up here. If you want to try something else greater than 4, go ahead, okay? So we got 4 here. And now remember that anything to the left of the inequality symbol is just like gems. Treat it like a gem problem. We have grouping symbols, so obviously we're going to take that inside that grouping symbol and break it down to one number. All right? So we got 4 outside. Inside these parentheses, what are we going to do first? Abby?
Multiply -3 and 4.
There you go. And 7 times, or excuse me, 7 or -3 times 4 is?
-12.
Nice. I'm writing over my work, but that's okay. Ooh, I forgot my negative. All right, so we got 4. And 7 minus 12 is? -20. Mm-hmm. Or -5, excuse me. I just did the problem. Okay. Now 4 times -5 is? -20. See, my head was... And is that true?
Yes.
Sometimes I go ahead and I'm asking a question, but I've already answered it, and I say it out loud. I do that all the time. All right. So we have this is true, so everything checks out. I know there's a lot going on up here. Can you follow this? Got it. All right, Jocelyn, what's up?
When it's like this, where you have to flip the sign, or it's like it could be equal to, I always like to not do what it could be equal to, because if you forgot to flip the sign, it'll still check out. So then you could get it wrong still.
What do you mean?
Because if it's less than or equal to or greater than or equal to, if you use the one that it could be equal to,
Mm-hmm.
then it'll check out no matter what sign you have in the middle, because it'll be the same answer as the other side.
Oh,
So
because
you
it would
could
be
still
say
get
it would just say greater than, or it'd be if it's greater than or equal to here. You mean? Or
Yeah, because if you forgot to flip, then it would still check out.
I'm seeing what you're saying. Yeah, that's a good idea. Not to use what the number is. Use something on the other side of it.
I don't like using it.
Huh?
I don't like using it because at the bottom always messes me up.
So use something different than what the dot is on. Maybe we should make that, because that's true. You're right. That could happen. Absolutely. Good point, Jocelyn. Anybody have questions of what Jocelyn just pointed out? So if it's equal to, we might want to use something different. Obviously, open we can't, so that prevents us from doing that, and that works. But when it's equal to, you're right. Because if I flip the sign around, does it really matter? Is -20 still going to equal -20, no matter which way the less than or this sign is going to? Doesn't matter. So yeah, I agree. All right, let's try another one. Come on, change. There she goes. Now, if you notice, we still have distributive property here. We all should know how, hopefully, to distribute a fraction, but could someone remind us, just for those people that maybe have forgotten, it's been a little bit of time since we've done it in the past. Jocelyn, you want to go ahead?
You multiply the top number by the number you're multiplying by, and then divide it by.
So the top number would be the numerator of the fraction, which is, in this case, 1. So you take 1 times 10, and then Jocelyn said divide it by the bottom number, which is the denominator, which is divided by 2. So 1 times 10 is still 10. Divide by 10 by 2, what do you get?
5.
5. All right, so our 10H, and really, I think most of you guys know that if you multiply by a half, isn't that really just cutting something in 2 parts or dividing it by 2? Yes. So it doesn't matter how you want to look at it. So 1/2, this is going to be 5H's, and if you half the other term, what's half of -6? What's half of -6? Great.
-3.
-3. All right, why don't you guys go ahead and solve that if you haven't done so already. From here. And I will solve it as well up here. You want to check out your first step? This is what I did.
So how come you never use the black marker?
Because it's the same color as the problem, which is typed. I use it once in a while. I don't know. I like to change. I like color.
You should go.
I can change the colors.
Yeah, you should do that.
I used to have purple, like red, and I can't use obviously can't use yellow, but there's some cool
I
colors.
like the purple.
Rainbow.
One.
There should be a rainbow.
There is a rainbow.
There is a ring, but it's really thick. You can't write with it.
There's also a smiley face one.
Yeah, see, but all those are really thick, and you can't really do anything for. So, are we flipping the sign this time? No. This positive thing, we're keeping it greater than. So h is greater than -4 is what I got. Is everyone cool with that?
Yeah.
Everyone good with that? All right. So I'm going to graph it, and obviously this graph we're not going to obviously use. So what's left of -4 in our number line?
-5.
Thank you. We got -3. Open or close that, guys?
Open.
Open. Which way is the arrow going to head? Left or right?
Right.
To the right, because it's greater than. All numbers to the right of the number from left to right is getting greater. All right, so I will use black. Olivia, are we good with that?
That's for me.
So now we're going to plug it back in. We got 10,
0.
and we got h minus 6 is greater than -23. Now, I heard 0. Would we hit 0 if we kept going to the right?
Yep.
We could. Are you guys finding out that, when I shared that 0 works the best? I think it does, and just because I can do things in my head. I make less mistakes when I multiply something by 0. It's something that's been ingrained in us forever. So, is that what you guys want to use, 0?
Yeah.
All right, let's do 0. Or you can, yeah, it's fine. So we got 0 minus 0 and -6 still in here. And then we have 1/2. And -6 is left over because 0 and a -6 is still -6. And then what's half of -6? -3 is greater than -23. Are you guys cool with that? Are you guys okay with? You guys agree that -3 is definitely closer to 0 on a number line than -23. -23. -23 is way farther in the negative. So, you guys feel good about this? You've done this, so make sure you don't forget to distribute. Remember, the only thing that I can see mistakes happening is you see this -6, making sure that you actually distribute it to that 1/2 to -6 versus just 6. Just making sure you get all with the signs. All right, that's just some careless things that I've seen. All right, now here we go. You ready?
Maybe.
No.
Yes.
Yes. No.
Totally.
Define ready.
Now, there's a couple things. First of all, does everyone look at the left-hand side? You all see that side looks kind of like a fraction, doesn't it?
Mm-hmm.
Right. And what our ultimate goal is to get what x is, or x by itself. And when you see a problem like this, the only way we can get the x by itself is, first of all, identifying is x in the top or bottom? The top. So remember how I used to box the variable term? The variable term is in the top. We have a numerator of the fraction. We have a denominator of a fraction. All right? So remember that when I box any variable, remember we always talked about getting that box by itself first. Getting rid of whatever operation on the outside of the box. What is the operation that's on the outside of the box, that's attached to the box? Huh? Division. Do you all know how to get rid of division? Because if we get rid of the division, wouldn't we just hit the top left? And then you could solve that. If the divide by 7 wasn't there, could you solve the problem?
Yeah.
So let's make it happen. Let's do that. Let's get rid of division. So when we divide, the inverse is what? All right, so we're going to multiply by 7. So to get rid of divide by 7, we're going to multiply by 7. And remember, when a 7's on top and a 7 on the bottom, what happens to these 7's? They go bye-bye. And all you have left is that box. So, but if you multiply by 7 over here, you have to multiply by 7 on the opposite side. Remember, you have to keep it balanced. Now look. It's a fraction. And I want you guys to pretend that, okay, if I can make a fraction go away, okay, if I had the fraction 3/4 and I want the 4 to go away, wouldn't you multiply it by 4 to make it go away? You'd have 3 left over. If you multiplied 1/5 and I want the 5 to disappear, wouldn't you multiply it by 5? So what we're trying to do is we want that 7 to disappear. So we're going to multiply by 7. Jocelyn?
Isn't it just the reciprocal
Of what, honey?
of the
That's how you get rid
denominator?
of it. She was saying you get rid of it by multiplying by the reciprocal.
Yeah, don't you just multiply by the
Yeah.
reciprocal?
No.
Kind of, yeah. Well, it's not really the reciprocal because this
X
is not,
plus
you don't
negative
see
4
1/7 here.
Isn't
Yeah.
always 1.
What?
Because x plus negative 4 isn't always 1.
Well, like if I had it like this. Now do you see 1/7? Now you can multiply by the reciprocal of this. Do you see what I'm saying?
It's still the same thing.
It is. But because you see why I boxed it, I pretend that there's actually parentheses around the top. Because can you divide two things by 7 at once? No. No, you can't. You can't do that. So we have to go reverse of what we normally would do. So we have to get rid of the fraction first. So when we do that, when you get rid of that fraction, we get rid of this 7 here. The only thing we have left is the box. So just like when we're in a two-step equation like this, when we add 4, and if we had this box, wouldn't we get this 0 pair here and we just bring the box down? So in this case, all we did was we just multiplied by 7, so now just bring the box down. So whatever's inside the box, there we go. Whatever's inside the box, we're going to bring down. And now, what's negative 8 times 7? Negative 56. So in this case, can you solve from here?
Yeah.
Now this goes back to like our first day of equations or inequalities with one step, isn't it? Hannah?
But you always like add negative 4 first before you divide, or
That's what I did.
No, because it's inside the box. Remember when I told you that box is kind of like that protectant? Because x is attached to the positive 4 right now up top. You have to leave it alone until you get that whole top by itself, and then you can take 4 off. Because the thing is right now, this side is in 7s. Do you see how complicated that would be to subtract 4 from 7s? Looking like that? Do you see how that's more complicated than you even want to deal with? So let's make it easy. Let's get rid of the fraction. Let's get rid of that division. All right, first. And then all we have is the top left over. And it becomes a, whoo! Look at that. That looks a lot better, doesn't it, what we have left? So now, the next step, obviously, would be what? How would you do next, Brian?
Add 4 to each side.
All right, we're going to add 4 to each side. And I believe x is going to be greater than, what, negative
52.
negative 52. And so, again, can I ask you, are these still two-step problems?
Yeah.
Yeah. Because you got one-step, two-step answer. So these are still under that two-step realm. They look a lot more complicated than that, don't you? I mean, it kind of looks kind of funky. All right, so we got negative 52. We got negative 51 on that side. We got negative 53. Andrew, open or closed? Open. Which way is it going to go, hon? There we go.
Use 0 again.
And Trey says use 0 again. Is that what you guys did?
Yeah.
You could? Anybody else have any other great imaginations what we can use? Besides 0? What if you didn't want to? Sasha, what would you do? If you didn't think of 0? Negative what?
45.
Negative 45. Why?
Because then you add the negative 4 and you get
So if you put negative 45 in for x, you add that to negative 4. Your top of your numerator of your fraction from the beginning would be something divisible by what? 7. So could you think of a lot of different x values that are to the right of negative 52 that could make that a multiple of 7? And you could make it what you'd like. Last hour they chose to put negative 10 in there. Maybe 11 would not be.
Just 11.
What about negative?
Oh, positive 11?
Yeah.
91.
Sure, then it'd be 1. Yeah, you could go that route too. Absolutely. Good, guys. Look at it. See, that's why I like you guys to pick your numbers and reason why you're picking what you're picking. 0 necessarily could be the easiest, as long as you knew that negative 4/7 when you put 0 in, right, is between 0 and negative 1. And this over here, negative 8, is farther to the left of that. That's what you have to make sure of. So here, you guys want me to use 0 or something else?
11.
11.
All right, we'll do 11. All right, so we're going to do this one, negative 8. Sorry. Use my black, don't look at my red. All right, so now we're going to remember, we have to simplify the top first, and that would be 7 over 7 has to be greater than negative 8. And what's 7 divided by 7? 1. Is this 1 greater than negative 8? Absolutely. All right, try one more. Oh, I forgot to write it in.
Is there a reason it's underlined?
Yeah. Because they're supposed to.
Oh.
It's supposed to be a fraction bar. I forgot. Type it in. So we're going to do what first in this problem? How are we going to get the x? Remember, if you want to, you can always box that top. But remember, we want to get rid of the 6. And think about what we're doing, what operations attached to the 6. So, Canyon, what would you do to both sides, honey?
You would times by 6.
Yeah, let's multiply by 6. Then we can get rid of that denominator and we can, woo! Did you know that's how you get rid of any fraction? If you don't want to work with fractions, you just multiply by the denominator. All right, so we're going to multiply by 6 here. We're going to multiply by 6 here. And this cancels out. And we have, that. Does that flip the sign?
No,
Yeah.
no, it's a positive.
Okay, so it doesn't flip the sign. But what if this was a negative 6? Then we could flip the sign. You see what I'm saying? All right, so we could flip the sign if you have a negative denominator there. So we got, what's 6 times negative 14? Negative, whoa, we're getting up there. X minus 3. And now we're going to, what do you do next? Lady, what are you going to do?
After you get that, you do plus 3 and 7.
Nice. So you guys notice that these problems here, you're actually doing the reverse instead of creating 0 pairs first and then dividing or multiplying. You're actually multiplying first, then creating your 0 pair. All right, so you're just doing it reversed. All right, so we got what? X is less than or equal to what? Negative 81. Open or closed dot? Closed. Arrow is going to point in what direction? Left. Remember, if you rewrite this, the little point is, you remember the x is, the little point is pointing to the x, so you could actually rewrite it like this. Okay? And now, what are you going to put in there now? Because 0 is not an option. Holy cow. Melissa, what would you put in?
I put 93
Why'd you put 93?
because you can put 6 into 90. Like, so if you had 93, negative 93, and then you put negative 3 with it, it's negative 96, and then negative 96 is divisible by 6.
Okay, all right. Anybody else have another? So you can put negative 93 in there. Anything else you can put in there? Jonathan?
I did negative 597 because when you subtract 3, you get negative 600.
That's a lot easier.
Okay, Jonathan, that's going. Hey, you're doing it. Wow. Didn't know we were gonna get that big, but hey, it's good. Yeah, 600.
It's actually that small.
Wait, so what did you do?
Huh?
It's actually that small.
Really small. Yeah, yeah. You're right. You're right. It's actually a really small number. Okay, Sasha.
I put negative 87
Okay.
because 6 goes into 90.
All right, so you're right there with Calissa. You're getting to that 90, 96, and obviously if 96 is a multiple of 6, you go back 6 with 90 also. You can make 90 in there. So any of those possibilities would. I'm going to go with Calissa since she was first here. Got to pick one of them. So we got, what, 90? You put 93 in there, right? Is that what you said? So we got 96 left over 6. And 96 divided by 6 is going to give us, is it 16?
Yeah.
And that, is that true? Is 14, negative 14 greater than negative 16? I agree. And I think you would have got 15, Sasha, right? You would have got 15 here. You would have gone one more multiple. You would have got 17 from where you were, okay, and so forth. Now, is there any questions? All right, I'm going to give you some more problems. I'm going to actually go back to our worksheet and let's circle which ones I'm going to assign tonight. Give you guys some playtime with these. Then we'll have a quiz tomorrow. On all the different inequalities that we had, all right, this week.
Are you going to
We're going to try, yeah, you're going to just continue on with the piece of paper that you started your problem.
I don't have any more.
Then just start a new sheet of paper, Jonathan. Right? You can't fit in them. If you can't fit any more, then obviously start a new piece. So circle 3 and 4, please, and 6. 3, 4, 6, and 8. There's 4 of those. All right? And then I want you to do number 12. Flip it over. 13 and 15, and number 22. So Olivia, you're gonna try that 22 again, and this time you're gonna get it right.
Well, last time I did, I didn't divide or multiply first. I tried doing top box.
There you go, and that will obviously change the whole result, wouldn't it? Not very hard once you know what to do first.